Hi, and welcome to this week's episode of Lights, Camera, Nashua. I'm Kathy Bailey-Smith, your host, and today we are filming an exciting episode here at Nashua Community College, right here in our own backyard, where there's some interesting technologies happening to prevent bird strikes on aircraft. So let's go inside and take a look at what's happening here at Nashua Community College with Lite Enterprises. And now we are sitting in the executive offices here at Nashua Community College, and I have the pleasure of introducing a couple of really interesting gentlemen. Bob Donadio.
Correct.
Am I pronouncing that correctly?
There you are, absolutely.
Great. And you are a former professor here of aviation technology, is
That's
that correct?
correct, yeah.
Okay, great. And Don Running?
Correct.
Okay. And you are the president of Lite Enterprises.
That's correct.
Excellent. And before we start our talk about the serendipitous meeting of the two minds at the Nashua Airport, I thought it would be fun to kind of learn a little bit more about you individually and what you both brought to the table. So if you want to start, Bob, that would be great. So I know as a professor here, you taught
Aviation maintenance.
Okay.
But my background is mechanical engineering.
Oh.
So I came from a manufacturing industry.
Right.
I had my own company in Hudson. I worked for Sylvania. They were making a product for the semiconductor industry. And Osram came in, GTE sold Sylvania to Osram. They were going to get rid of the department. And so instead of finding another job, my father was also a businessman. We got together and we came up with a business plan, and we moved the production to Hudson, New Hampshire. And so we moved it from Exeter, Hudson, and we were in business for probably about 10 years, and then sold the company to Morgan Advanced Ceramics, and it's still there on Park Ave. And so that's my background, is manufacturing, bringing concepts and ideas, customers' needs, but mostly manufacturing, nuts and bolts, chemistry, and that sort of thing. And it was our company, so I get to make all the decisions, and it was a lot of fun. And I used, at the time I was a pilot, and I did use my own airplane for business. And it was fun, and it was very productive to fly customers to parts right to their door, and to bring my accounting team with me, engineering team with me. And so the general aviation part of it was a kind of a side for it. And then when I sold the company, I started to get into my own maintenance. And my boss, currently, Don Valorant, he was my inspector. And so little by little, we started working on the plane together. And I attended Nashua Community College. Back then it was New Hampshire Community Technical College. And so I'm a graduate of the program. This is my alumni. Come to a few years later, someone else was retiring, and I decided to try myself at teaching. And so they hired me. I've been here 7 years.
Wow. Did you like teaching here?
I did like teaching, and there's a feeling you get when you make a difference in an individual, and you see that the light bulb light up, and they finally get it. And so I got a little taste of that. And so I'm trying to move on and do other things, and then we hooked up with Dawn. And I like the marketing part of the program and the college. So I'd like to take an effort and just try and improve the program, get more students involved in it, popularize it. No one really knows we're here.
Exactly, and that's interesting that you say that, because that's very true. I didn't know they haven't had an aviation technology.
My boss calls it the best kept secret in Nashua.
Right.
But if you're not into this, you wouldn't really care that we're here.
Right, and so who might be a candidate who would be interested in that?
Oh, any kind of young adult, old adult, someone who's mechanically inclined, who's always had a fascination for aviation, and likes solving problems. And so that's the opportunity that the career gives you. It allows you to solve problems, use your head. And it's kind of a, higher sort of status of being a mechanic than being a, Jiffy Lube kind of, or, garage mechanic working on cars. This gives you a little more status. Not a heck of a lot of extra pay, but a lot more responsibility. Right. And so that's what you're looking for, someone who's responsible, someone who's respectful. They've had a good upbringing, and they're mechanically inclined, and they want to be dedicated to a different career path. Also, but military too. Come out of the military, and if that's something you've ever had an inkling in, you can join the program, and a year and a half later, you're a mechanic. Right. So that's sort of what we're doing.
Interesting. What goes on in our community, we don't even know sometimes.
Exactly. It's the whole idea.
So I'm excited to be here.
Well, thank you for your help.
And Don, how about you? Tell us a little bit about what your history is as it pertains to where we are today.
Sure. My background is rather unique in that I grew up in the Midwest. I've been interested in terms of wildlife activities and flying from a very young age. I have 2 undergraduate degrees, chemistry and photographic science. I worked in the electronics industry for a number of years, and I've been working independently for the last 20. I have a small company that's located next to the airport in Nashua. I had an idea based upon a number of meetings and discussions with people in a number of different areas that I saw that new technology could be applied potentially in terms of minimizing aircraft bird strikes. I had this idea. I submitted a proposal to the National Science Foundation, which I was awarded a grant, which has helped me in terms of financing the research, the study of the activities. And now we're deep into the activities of trying to commercialize this particular as a product that could be applied to the aviation industry. Where we're at right now is that I had the opportunity through contacts with people at the airport and other people that the Nashua Community College could participate in the grant activities in terms of developing a working prototype system. And that's how I got involved with Bob and the Nashua Community College.
One thing I need to ask, how does one get involved in the interest of bird strike? I mean, where does that come from? Like you have this idea, you just have an interest in wildlife, an interest in, how did that happen?
Well, it turns out that I understand quite a bit about photographic science and chemistry and the way that neurophysiology works within humans as well as animals. I understood the requirements in terms of being able to get a startled response from birds. And with that, we're able to induce a behavioral response. When an aircraft is flying at 150 knots, you don't have a lot of reaction time. And there's a fair amount of video, not a lot, but a fair amount of video of bird strikes occurring with aircraft. And from that, you see that the reaction time is typically less than a second. The bird may be aware that it's about to be struck. But if you can increase that reaction time even by a fraction of a second, you can go from what potentially would be a bird strike to a near miss. It's good for everybody. The cost to airstrikes to the aviation industry is about $800 million per year in the United States. It's about 2 to 3 times that worldwide.
Wow. And that's something that, I mean, we have heard of some airstrikes obviously affecting flights, but it's not something that we talk about every day. So it's kind of interesting that I didn't realize the financial impact that this takes on, you know,
it's
in our
quite
society.
substantial, and it's something that a lot of people have been working on for a long, long time. There are a number of mitigation techniques that are being used. Put up fences around the airport, mow the grass, things of that nature, which are all having an impact statistically, it's proving out. The FAA has a 25-year database which is maintaining the bird strike incidences throughout the United States, which is very informational.
And so you followed that, saw a need, understood what was happening,
Yes.
and said, listen, this is what we could do.
Yes.
Yeah, interesting.
It's an interesting idea.
Yeah.
Now, just having an idea doesn't mean that you have a product. There's a lot of steps. And the regulatory process of the FAA requires that there is a good amount of research that's done. And then ultimately what we need to do is to prove the value or the effectiveness, as well as minimize the risk in terms of aircraft safety overall.
Of course. And that's where you two, you're at the airport, Nashua Airport, right here in town,
Having
having
lunch.
your coffee, having lunch.
Having lunch.
And so how do you meet each other? How did this happen?
That was Sandy. The airport restaurant is a relatively small restaurant. Lots of people go there for the view, and mostly pilots. Being a pilot, we were there having lunch one day, and Sandy introduced me to Don. Sandy Adams is proprietor. She must have got wind of, you must have either asked her or she overheard a conversation of something, because somehow she realized he could have used a little bit of aviation information. So all she did was make an introduction.
Right.
We swapped business cards, and the rest is history. Well, lots of things were started accidentally.
Yeah.
You know, lots of inventions came, accidentally, synthetic rubber and things like that. And so I, don't think it's a circumstance. I think it was just meant to happen, just happened that day,
Right.
that particular time. And then taking advantage of it, whatever you need to do. The college, to get the college involved, is just very good for the college. It's a feather in the hat, exposing the students to private industry. And we try and, mimic what the real world is like with the students. And this was, this is just a good adaptation. So we just followed it along.
Right. And so how long did this lunch last? I mean, I would imagine after meeting, you figured...
He was having lunch at the time. I didn't want to bother him. So the initial meeting was just exchanging cards and, hey, we should get together.
Yeah.
Then subsequently, I went to the office, his office, and we started getting together and started writing things down and solidifying things. And I was just excited to do something different, expose the students to it, that sort of thing. So
Right.
that's it. It's all fun.
Well, that's what I love is the collaboration between the community college and private industry.
I know,
and
right?
being able to partner together to create something.
Mm-hmm.
And so I found that really interesting. And so what has the process been like? So you kind of talked about what was needed, you talked about what your idea was, and then what was the next step?
Well, in essence, you have an idea, but you need to also work through the technology aspects of it. I'm using technology which is really newly available, recently developed. So nobody has taken this particular approach in terms of addressing the issues. What you need to do is to collaborate with a number of people. I am actually also working with the New Hampshire Audubon Society in terms of doing field studies. We're soon to be publishing a paper showing statistically that we have positive results in terms of deterrence. It's not in an aviation environment, but it's very likely to translate through. So what you do is you look for what's the next step in the process. How can you move yourself forward? And clearly we were moving forward to the point of wanting to manufacture parts that could be integrated into the aircraft itself. And the skill set, the resources of the community college was very complementary, and certainly working with local people was very advantageous.
Oh, absolutely. And so you, knowing that they needed a device to hold, or Don needed a device to hold this light into, were able to take the idea and then
adapt it to, what is currently available.
Right.
So it could have been even a separate unit or working in conjunction with something which already exists.
Right.
And so we put our heads together and came up with replacing the existing landing lights, which are used for the pilot just to see where he's going at night, and using it as a dual purpose.
And
Now,
this is it right here.
this is it right here. That's right. So our students made the box for Don. Originally, it was going to be a piece of a wing, I believe, and it was a specific airplane in mind. And it ended up being that it wasn't going to be just for a specific aircraft. It was going to be general. So we just hammered out some aluminum, and the students built this, as part of their project. And so we simulated the actual mounting of the light, and the electronics and the switches. And so, he did the rest. He designed a dual wavelength so that, the pilot can see where he's going. That's that purpose, which is what the FAA cares about. And then he worked in all the different other wavelengths for the magic that scares the birds away. And so, we're on our, I think, second or third iteration.
Wow.
But the communication back and forth is really key.
Right.
I mean, so there's very good communication, sort of like having all your engineering departments in one sort of location.
Right.
And yet we're in separate buildings. And so we've gotten a lot of other people involved. And it's just been, it's been awesome.
Right.
And so he's got a pretty good concept down. We're just going to prove it, make sure it works, tweak it, and then go test it.
And so before we talk about like how the testing and what that protocol is like, I want to see more of this technology. Could you explain this to us, Don? Or?
Sure. In essence, this is a box that has been fitted around a landing light. This particular model, we decided since Bob volunteered
by airplane.
Which is a twin-engine Cessna, which is a quite nice aircraft for flying this. It has a retractable landing light. We bought some spare parts in terms of the retractable landing light, and this is the unit that is actually powered, and we're using it as a test model. The retractable components that's inside of this box looks like this. This would be the drive mechanism, and there is a can, a motor that actually moves the light down and forward. Mounted to this particular shoe is this, which contains the landing light itself. There's a protective shell that goes around the actual bulb. Now this is a standard incandescent bulb, specially designed for landing light purposes. This requires 250 watts of power.
Yep.
We have to deal with the DC current and the amperage and the electrical circuit requirements. But in essence, this is the standard landing light bulb on almost all aircraft today.
Mm-hmm.
Different sizes, different wattages. What we're doing is we're replacing that landing light with an LED version which contains the multiple spectrums of emitters which are being pulsed in at different wavelengths or at different frequencies, which give us the wildlife deterrence. What we need to do is to make all the appropriate considerations in terms of the design that are necessary to maintain the voltages and the amperage restrictions of it, but also to maintain the thermal requirements of the LEDs itself. So this is our first prototype of the unit, and now we're making some additional modifications, and we're going to be bringing this product forward for qualification shortly.
It's very exciting. And so I understand. How is it different than the original light? What is it doing that the original light didn't do? Do you know what I'm saying? What's the advantage of this?
There's two functions of this landing light. One is to act as a landing light itself to aid the pilot. So you need the visible portion of the spectrum. You need the intensities and the brightness. The second part of that is that we're adding wildlife deterrence capabilities of a very high brightness system. The way to think about the way that this works is humans experience solar glare or solar glint. We're inducing the same type of response that a human would have with solar glare or solar glint. It's different, but it's very similar, and gets into the deep neurophysiology of the bird systems, the bird's physiology itself, in terms of being able to induce that behavioral response.
And so it makes the bird want to flee or fly, or...
The first most important thing is yes, you can either get the flight fear and flight mechanisms, but at a distance, what you want to do is you want to make them aware that the aircraft is in the vicinity. If you get their attention, they typically respond.
Wow, and so you've tried this.
Well, the FAA is very specific. It cannot fly unless it's approved. Right. So what he's done is this is the prototype that we're developing. Right. There'll probably be a couple of levels of testing. One would be, say, a handheld version to test the effectiveness of his technology, and the other one would be a flying version. And then the flying version has to have FAA approval. And that's the long, drawn-out process.
And what is that process like?
Oy, oy, oy. Do you have enough film? It's every piece and part that goes into the plane has to be, strictly controlled with the mil specs. And when you bring something like this into it, even though it looks like a lamp, it has a plastic cover, it has light-emitting diodes, it has the aluminum screws. All of it has to be approved, the amount of power it uses. This may put out electromagnetic interference where regular bulbs do not. So all of that has to be tested. The part has to be exposed to all the different environments that it's going to be exposed to. Up in the air, salt, humidity, vibrations, very key on vibrations. So all of that has to be done with outside testing and over again, so that the data is available and so the FAA can basically give it its blessing. When they do give it a blessing, Lite Enterprises will be awarded what they call a supplemental type certificate. And so now the part itself now has approval. And now he'll go and he'll get the approval to put it in my plane, and we can fly it and test it. You do that, you put it in, he'll go and get approvals for other airplanes. And then that same technology can be used for the larger airplanes, the ones that could save several lives. Like the one that went into the Hudson River. So those are different sizes. Again, the lights are there for the pilots right now, so that we can see where we're going at night. And so, once the part gets approved, and then we can, test the effectiveness of the wildlife deterrent system.
And what is the time frame on that approval process? Do you have any idea?
Well, best case is 6 months, I believe.
Right.
To go through all the different certification processes, it'll probably be 1 to 2 years.
Wow.
Yep.
So it's a lengthy process.
It is. It is. And this is probably why aviation is still sort of old and antiquated. You know, my airplane's a 73. It still has old magnetos. It still has, you know, old analog gauges and things like that. It's hard to bring stuff like that to market. Newer airplanes have a better shot at it because they're starting from a clean slate. But the approval process is rather lengthy, and it's for safety, 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 safety. That's all they're concerned about. They don't care about.
We understand
I'm
that.
sure they don't
Yeah.
care about profit. It's all about safety, and so they don't want this thing burning up. They don't want it causing fires and things like even stuff that does get developed. Still, when it's in use, causes problems. I mean, you probably heard about batteries and things like that for the Boeings that at one time were causing. It was supposed to be new and improved, and they had issues with them after they're in use several times. And so that's to try and avoid that. The process is rather lengthy. So I sympathize with them. We'll do what we can to speed it up. But this is relatively simple. That lamp that he showed you was, when did you say it was developed? 1950 something?
That's amazing.
Yeah.
1952.
And it's the same lamp. It's just a filament bulb and made of glass. And so this is a little bit more complicated. So, you know, and the standards back then were different than the standards of today.
Right.
And so you're going to have to design something that, you know, satisfies 2016 standards, not 1953.
Right.
So, and that's going to take a little bit more time.
It's hard to believe that nothing has changed with that since 1952. I mean, in the
Yep.
era that we live in, you would think, right?
Well, LED technology has been recent. You must come across LED lights
yeah.
in a house and things like that, phones and whatnot. And so there is an LED replacement light, but it's just for the pilot.
Right.
And what he has done is come up with a better light for the pilot. So it's not just a substitute for this. This light will throw extra light that is brighter, that is more appealing, and reflects back to the pilot better. It's a wider spectrum, in addition to the bird deterrence. So it actually is a better landing light.
Right.
It should be easier for us to see farther through the, you know, bad weather and things like that.
So Bob, I understand that the prototype is being developed here at the college.
Correct.
Can you kind of walk us through what that's
Well,
like?
he needed an example. And so I had my airplane. We went to the airport, we took a look at it, and I asked him if this was going to work for him. He said, sounds like a good starting point to me. So we took the landing light fixture, we bought some extra fixtures, and the bulb has already been in production. It's a General Electric bulb. This is just how we started it. We modeled the existing bulb, knowing how it has to mount. He has design requirements for his new design with the heat sink in the back. You know, the machine shop there did a drawing of the existing bulb. He has his own modification to it. We bought the aluminum, hogged it out ourselves in the machine shop. So it's really sort of an advantage to having an engineering concept and an idea real close to the ability to prototype it, the machine tools themselves. And you know, this is what the college is all about, bringing ideas to a pieces part. But we did start with an existing bulb that was already in existence. So we didn't start from scratch. And that's how we came to this particular model. But it's directly adapted to all the other ones too. They can make it bigger and they can make it smaller.
Great, it's very interesting. Hi Mark Masse, thanks for sitting down, lab assistant here at Nashua Community College.
That's correct.
Okay, and so tell me a little bit about what your role was in this design. So,
Well, they came to me and asked me to design a housing, an aluminum housing for the LED landing light. And you know, we had to take into account all the other pieces that were involved and design something that worked for them and met their cooling requirements and you know, fit in an existing you know, landing light housing. So my role was to, you know, design something that met all those criteria.
very cool. And you showed me over here the design. Can you explain a little bit about what this is?
Sure. Here we use SolidWorks. It's a computer-aided design program that enables us to very precisely create things in a computer and see how it fits in with other components that weren't necessarily made by us. And so we can adjust our design to fit other components very precisely. And we use this model as the basis for our final product. And it makes it easy to adjust and and adapt the design to the changing requirements.
And so the model was designed here or made here. Tell me a little bit about what the equipment that you
right.
used here. Yeah.
Okay, the equipment that we used, well, you know, first, once we had the design set in our computer-aided design software, we ended up printing a 3D model of it, and we used this 3D model to test it with the other components, just to make sure that it's what we want. And once it is, once we've determined that it meets the requirements, we'll actually turn a piece of aluminum into one of these. We initially, you know, for the first prototype, we used very basic prototyping machines to do that. And once we have that aluminum version and it's all okayed, we move that onto the computer numerically controlled machines that can make very accurate copies of anything we program. So that's kind of the process that we use to go from computer to a finished product.
Very cool. So it sounds like an interesting project. How long did it take you to between design and then completion?
Well, you know, we do a little bit at a time, and then we check with we check with Lite Enterprises to see if that's meets our requirement. And once we get that kind of fine-tuned, there's a lot of give and take there between what the requirements are and what the manufacturing capabilities are and what's practical. Once we have that nailed down, I'd say we probably have off and on 3 or 4 weeks of back and forth to get to a single prototype.
And then the finished product.
And then the finished product, again, we're on our second or third iteration of this project. So, you know, we can see that this is the first or second generation, and we're probably up to the 4th generation, and it looks a lot different than what we started off with. So now that we've determined that this is what we want, and all the other components are going to fit onto this, this is what we're going to be making, and we'll do that on the computer control machine. So there's a little bit of adjustment. Our software here will take care of any adjustments, and we'll just program to make that, and away we go.
Well, excellent. Well, thanks so much for telling me what your job is on this project. It's kind of exciting work.
It's fun. It's fun. It's great work.
Yeah. Very good. Well, good luck.
Well, thank you.
Thank you.
All right.
Now we're joined by Mark Dodge, who is a professor here of precision manufacturing here at Nashua Community College. Nice to meet you, Mark.
Well, it's nice to meet you, Kathy.
And from what I understand, these machines are used to design, or tell me a little bit about what they do exactly for this project.
Okay, well, you'll take the design, and from that you'll extract geometry, and you create the geometry in real life on these machines. So you use that, once the design is finalized, if you will, you take this and you write a program. The program is written in code. It's called G and M code, but we use a computer to generate that G and M code. It's really rather complex, but with the computers, it makes it rather simple.
Sounds complex to me.
Well, it is if you had to write it out by hand. You could make this machine go by sitting down at your word processor or actually a text editor and writing in the code itself. But for a project like this, it takes a computer, because of the shapes involved and so forth, to write the code to make this go.
Oh, wow. And so precision manufacturing, what exactly is that for people who might not know what that is here at the college?
Okay. Well, precision manufacturing is the utilization of computers and computer-driven machine tools to make parts to close tolerances. In this case, and this is a good example of it, this Lite that's being proposed, this is an excellent example in the utilization of all these technologies. We use the 3D printers to generate models. We use the 3D, what's called SolidWorks software to generate the models from which we can print the part itself. But to turn it into metal, you need to make the machine and go and cut the metal in the geometry that you want. That's what Mark Masse's been doing on these prototypes. And here we have some that will be kind of a short production run for this particular project.
Right. Well, it's very interesting work, and I'm really excited to showcase this
Oh, good.
on Access Nashua, because the project itself is really interesting, and just the collaboration between the college and private industry is really interesting.
Well, I think it's something that we can do more of. To tell you the truth, it's an excellent opportunity for all concerned. Mark has been instrumental in doing the work for this and taking an idea, a concept, and turning it into metal. And I think that's something that we can really highlight and showcase, because this is kind of what machine shops do now. If you look around, you'll see that this is not the greasy, oily, dirty environment that you might think of as a machine shop. But it takes a lot of computer skills and it takes the mechanical skills, if you will, to make this machine go and to do what it's supposed to do.
Well, thank you very much for explaining this to us.
Oh, good.
Appreciate it.
Well, thank you, Kathy.
So Don, from what I understand, after you and Bob met and exchanged ideas, talked a little bit, you ended up going into the classroom here at the school.
That's correct. One of the requirements of the grant from the National Science Foundation to the community college was the requirement of involving the student bodies in the activities and the process. Bob and I talked about how we would be able to do that in terms of both hands-on and lab experiences, as well as go through the resources of prototyping the system. Bob, maybe you want to speak more on that.
Well, eventually, when he came in and discussed it, the program's going to have certain phases. The students were involved in what those phases are, and the curriculum that we have starts off with courses generally for aviation. And so it happened to be I was teaching forms and records, which was one of the classes that we were doing, which is how to get things approved. And coincidentally, and so that was involved the students. We had a little roundtable discussion. I believe we got a surprise inspection by the FAA, but that particular day, and they were actually thrilled that we were getting the students involved. Because the approval process is, strictly FAA. And it was going to be a piece of an airplane wing. The students were going to do the fabrication. Metal fabrication is part of the curriculum for the other courses. And then eventually turned into, a box. But when the part gets approved, that's a process that we review in forms and records at the beginning, but we don't actually have any examples. And so now, the class of 2017, they have an example. And they've been directly involved in this. Don came in later on, we form-fitted the parts, and they punched this up, they made it work, and he's used it in his shop. So they get to be exposed to the whole process. This is going to help them bring ideas to whatever, solve problems, develop new parts, and the student involvement is key. Not many other programs can say that. So the students very good feedback. I mean, they have fun. I mean, you're breaking up the boredom.
Yeah.
You don't want to listen to me talk. I'm boring. When you have something to pass around and you're talking about real life examples, and with airplanes occasionally being in the news for bird strikes, it's real life. It's real life, and they get involved in it. They have lots of ideas.
Right, that's exciting. And it must have been interesting too for you, Don, to kind of engage with the students here.
Well, their enthusiasm is really
Yeah.
interesting. It was good to see that they were excited about the activities. A lot of them really were not aware of even the issues. So, and you never know. Sometimes there's some nice ideas that come from the students as well.
Right, which is true too.
Absolutely, yeah.
Yeah.
That's the workforce of tomorrow.
You have a certificate number from the FAA
Yep,
to qualify students.
That's right.
The fact that you needed to have that inspection, and it's mandatory as
Yep.
part of your certification process.
that's right. Yeah, so he comes in, and it's every, several times in a year. And so, one of the things that he did this particular time was a surprise inspection. I let him know that this is what we're doing for forms and records. We're getting the students involved in this discussion. Geez, I hope you don't mind. He was all for it. Again, this particular inspector realized the value of getting the students involved in a hands-on type of thing. And then we would go into a future syllabi, adding to the syllabi with the approval process itself, in this particular part of the approval process. So that's all, part of the syllabus, and the way we have the courses lined up is when you start the program, you learn the basics about the aviation, the rules and regulations and how to do things. Then you start actually getting into it, and after 5 semesters, you've done the whole thing. Now you can become a graduate. So this was at the very beginning for the approval process. It was excellent to get the students involved, and it was very informal. It was seriously a roundtable discussion, and the FAA happened to come in, and Don did an awesome job presenting, and they're just, they like to see that involved, because I believe it, for the particular inspector, it adds value to him overseeing the program, and he can now say, hey, look what our students are doing, look what my guys are doing, look what this program is doing. And we have to do that because NCC has the approval process. We're a Part 147, which is an FAR approved program. We can add to their basic information, but we can't take anything away. So here we are showing this this inspector. This is how much value we're adding to the program. This is the interaction that was going on with the students. And so he's all for it. But it's a totally different branch than the people who are going to approve the physical lamp itself. So, and believe it or not, they don't talk to each other. They don't even, you ask these, who do I go to? And they're like, I don't know, look it up. They don't really, they're very finite and specific in what they're responsible for. They're not very broad, in their activities. So we'll be getting involved with the approval process with the people in Burlington, Massachusetts. The people who come in and check our program are from Portland, Maine.
Interesting.
Yep.
And so where are we today? Because next time I meet with you,
Yep.
where will we be? So today versus next time we come in and sit down and talk again.
Well, today we have a working prototype of the lamp itself, using the resources of the machine shop, computer-aided design, computer-aided machining, the college itself, the communication that goes back and forth between aviation and machine tool. And the next part would be, this is the part that's very time-consuming, is to actually get this part FAA approved. And that process is a rather lengthy process, and it goes beyond the resources we have here at the college. And so we probably will go outside the resources here at the college to involve a more professional organization to give it more solid foundation. And we have spoken to those people before. The testing process is rather involved. I mean, you think about it, this thing has to fly in fog and salt and rain and everything, and that's where all the testing's done. And that takes several weeks, it takes months. And so right now we're in the process of supplying him with enough of these parts so that the testing people can smash a few destructive tests and do some actual testing to them, and then he still has parts left over that function to do the actual function test, which we plan to try at the Nashua Airport to see if it actually does the job that it's supposed to do. Holding it in your hand, maybe mounting it in something like this just to test its effectiveness. But before it flies, it has to have that stamp of approval. And so that's where we are right now. And so we have our machine tool capability. They're going to make up a bunch of these things. I think we'll probably need about 8 for testing. Some will get destroyed, but he should have probably 5 or so to actually have that still work and function. And then we can actually take it to the airport, turn them on, see what happens, and he'll collect all the data. And the rest of it is the paperwork.
Right.
Yeah, that's pretty involved.
Right.
Yeah,
That's
the
what
FAA
it
is
sounds
all
like.
about paper.
And that's what you manage, the paperwork process, correct?
Well, there's a number of people that have been involved throughout the entire project. The project's been underway for 4 to 5 years, the original idea. It's taken some time to get to this point, and there's still several steps to go.
Right. Well, it's very exciting, and I hope the next time I see both of you, it'll be at the
It'll
airport.
be at the airport, right? Cool.
Love to have you.
And so anything else that we would want viewers to know? Anything else that you think is important for people at home to know about the project or what's happening?
Well, this is a derivative of only one part of the wildlife deterrence technology that can be applied within aviation, but not only on the airplane, it can also be applied directly on the airfield itself. And there are other applications and markets that we're taking a look at that would be a derivative of this activity.
And what's your website so if people wanted to learn more about what you do, Don?
Lite, L-I-T-E, enterprises.com.
Great. Excellent. And Bob, thank you so much.
No problem. Thank you.
Anything else that you think
I would
people
like to
wanna
just
know?
let individuals know that this program exists at this college. It's right here on Amherst Street. Lots of opportunity in aviation. So if you're mechanically inclined, you have sort of a love for aviation, a passion for it, that this exists. Not many people know that this program exists right here in Nashua. And the only other programs that do exist like ours are up in Vermont. There's a new one in Plymouth, Massachusetts, and there's one in Bedford, Mass. But that's it. And so, you know, local to this area, it would be nice to have more students involved in the program, get more ideas, more problems solved, and, you know, get these guys out in the market and get them working.
Wonderful. And so folks can find Nashua Community College online.
Yep, it's nashuacc.edu.
Okay, excellent. Thanks so much, guys.
Sure, thank
Really
you.
Nice meeting
Appreciate
both
it.
of you.